Alright, in this lesson we'll explore the DT accessor. Now this is very similar to the STR accessor. You may recall that from our working with text data module. You may recall that when we were working with a series of strings and we wanted to call a string method, we had to pass that .str prefix in order to get any of our string methods to work across the entire series. Well, the DT accessor is basically the exact same thing. In order to access an attribute of, let's say, a series that consists of date times, we have to prefix it with that DT accessor before we get any of our attributes. So let's begin by creating a datetime index with our dateRange method, which we're now pretty familiar with. So I'm going to call the dateRange method directly on my pandas library. And I'm going to use my first approach of providing a start point. Let's say January 1st, 2000, an endpoint, which is going to be January, or rather, let's do the end of 2010. So December 31st, 2010, and let's do it at a frequency of 24 days. So within those 10 years, it's going to generate a large datetime index, 168 values. Each of the values here is going to be separated by 24 days up until it reaches the last part before December 31st, which is going to be December 22nd, 2010. I'm going to store this date range or this date time index in a variable. Let's call it bunch of dates. And what I'm going to now do is to feed this data set to a pandas series constructor. So now we're going to have a series of those dates. And I'm going to store this series in a variable called S. I'm going to preview S, so you always have a reminder of just what it looks like. So we've basically used the dateRange method to create essentially a datetime index, which you can think of as an array or a list of dates. And we've now passed that as our data source to our pandas series constructor to create a series of datetime objects. Each one of these internally is represented as a pandas timestamp. So let's say I wanted to extract the day from each one of these values within my series. If we have something like S here, we can't just call an attribute like day, which we could on a normal timestamp object or datetime object. As I mentioned, we have to prefix it now with a new accessor, which is .dt. Exactly the same as .str, but this one is concerned with date times. Now if I do this and I press tab here, I can see all of the available options that I have. So if I want something like day here, now from each value in my series I can extract a day, and that's of course going to be returned as a brand new series. So for example, in my very first row I have January 1st, so my day is 1. In my second row I have the 25th of January, so I have 25 listed here, and so on. So that's a really easy way that you can create basically a brand new series that represents the day of the month, and you can use that for any kind of filtration process or maybe some kind of business logic. And similarly, I have things like month. That will give me the month, so you can see which month is the most common here and things like that. We also have a couple of helpful ones. For example, let's say I wanted to find out the weekday name, what day of the week this actually falls on, and I wanted the full name, Monday, versus Thursday versus Saturday. This is especially helpful, let's say, when you're dealing with something like financial data. Maybe you have stock data and you want to see what day of the week a stock performs most successfully on. Well, we have an available option here called weekday name. That's going to loop through all of our timestamps and give us the name of the week, or the name of the day during the week rather. So you can see, again, we talked a little bit earlier about what's the advantage of having date times instead of strings. Well, the advantage is that we have access to all of these available attributes and methods that allow us to very quickly do something like this, find a day of the week that each date represents. If it was just a string, pandas would view it completely as essentially a bunch of characters strung together, and there's nothing that it could analyze from it. Now we have the opportunity to do things like operations like this. So let's show an example of how this could be useful. Let's say we have this series of dates. Let's pretend this is just a series of important dates in our company's history. And let's say we want to see which of these dates fall on the start of a quarter. Now, quarters begin, of course, on January 1, April 1, and then let's see, 4, 5, 6, 7. So July 1st and then October 1st. Those are the start of the 4 quarters throughout the years. Well, we have a available attribute here called is, and you can see a bunch of options here, but we have is quarter start, as well as things like is month end, is month start, is year end, a lot of different options here. Let's say we want to check is quarter start. This is going to be a Boolean, so it's going to return a true if that date falls on the start of a quarter, and it's going to return false if it does not. So this is going to generate a Boolean series for me. And now that I have a Boolean series, obviously the usual next step is a filtration. So if I assign this Boolean series to a variable like mask, and now I do month, or rather s, which is the name of my series, square brackets, and then give it that Boolean series as my argument. Now I'm going to pull just those dates that start at the start of a quarter. So there I have, you can see only those dates that fall on January 1st, April 1st, July 1st, or October 1st. Similarly, if I want to pull just those that fall at the start of a month, I can do something like is month start. And there you can see I'm pulling all of those dates that fall at the beginning of a month. I can do is month end. That's going to pull me all of those dates that end on the last day of a month. So you can kind of start to see how quickly we can now analyze and filter and perform quick operations on this data because we're working with these timestamp objects, which are also, by the way, optimized for things like speed and efficiency. The way that Pandas operates on the back end is differently from the way that something like a Pandas, or rather a Python datetime object works. So Pandas takes care of all the efficiency, all the operations, all the logic. All we have to do is basically write these 2 lines of code, and we can see how many dates fall on the end of a month. And imagine applying this to financial data that runs for days and goes back 50 years. There's quite a lot of flexibility, and as always, Pandas will perform these operations within milliseconds. So that's just a quick introduction to the DT accessor, and in the next lesson we'll actually be diving back into our terminal to install a new library that's going to fetch us a financial data set, and that will allow us to see a real-life data set that actually includes the Pandas timestamps in a date time index, so we can see how we can work on real-life data, what a typical financial analyst may do. So I'll see you there.